In this video, we are going to learn about the generation of computer. First, we're going to tackle about the classification of generation of computers. The evolution of computer technology is often divided into 5 generations. The first generation in between 1940s to 1950s is what we call the vacuum tube based. Then the second generation in between 1950s to 1960s is the transistor. The third generation in between 1960s to 1970s is the integrated circuit based. Then the fourth generation in between 1970s up to present is what we call the microprocessor. And the fifth generation from present up to the future is the artificial intelligence based. So let's talk the computer generation in their basic terms. First is the vacuum tube, an electronic device that controls the flow of electrons in a vacuum. It is used as switch, amplifier, or display screen in many other model radios, television, computer, and etc. The vacuum tube works by controlling the flow of electrons through a vacuum using thermionic emission. Most common examples of vacuum tube is the ENIAC, EDIVAC, and UNIVAC 1. And the next one is the transistor, an electronic component that can be used as an amplifier or as a switch. It is used to control the flow of electricity in radios, television, and computer, and etc. Act as a tiny electronic switch or amplifier controlling the flow of current to represent the binary 1 to 0. One example sa transistor is the MOSFET or the metal oxide semiconductor field effect. Then the FETs or the field effect transistor, and lastly the BGTs or the bipolar effect transistors.
Integrated circuit is a small electronic circuit printed on a chip that contains many its own circuit elements. So, an integrated circuit is a very small chip made of silicon that holds many tiny electronics. Parts such as transistors, diodes, resistors, and capacitors. These parts all work together as one unit instead of using many separate components. The integrated circuit combines them into one chip, which makes computer and other electronic devices smaller, faster, and more reliable. Microprocessor, an electronic component held on an integrated circuit that contains a computer's central processing unit and other associated circuits. So, a microprocessor is a special type of integrated circuit that contains the whole central processing unit of a computer in one single chip. It processes the instructions, performs calculations, and manages the flow of data. The first microprocessor, the Intel 4004, was invented by a team of Intel engineers Federico Faggin, Ted Hoff, Stanley Mazur, and Masatoshi Shima. Their groundbreaking work, completed in 1971, involved creating the first single-chip central processing unit that could run a computer's operating system, CPU or Central Processing Unit. It is often referred to as the brain or engine of a computer, where most of the processing and operation take place. The CPU is the main part of the computer that carries out instructions from program. It performs 4K tasks, arithmetic, doing calculations like addition or subtraction, logic, making decisions like comparing numbers, control, telling other parts of the computer what to do, input-output operations, managing data that goes in and out. In modern computers, the CPU is built into the microprocessor chip. That's why the microprocessor and CPU are often thought of as the same thing. Magnetic drum, a cylinder coated with magnetic material on which data and program can be stored. So, a magnetic drum was one of the earliest types of computer memory. It looked like a metal cylinder coated with magnetic material. Information was stored on its surface and could be read or written by a machine. It worked like today's hard drives but was much lower and stored far less data. So, magnetic core memory uses arrays of small rings of magnetized material called cores to store information. So, magnetic core memory was the main type of memory used in computers from the 1950s to the 1970s. It used very small magnetic rings called ferrite cores. Each ring could store either a 0 or 1 binary. This made it the first reliable type of random access memory before modern semiconductor memory like today's RAM chips was invented. Machine language, a low-level programming language comprised of a collection of binary digits that computer can read and understand. So, machine language is the simplest and most basic programming language. It uses only binary code like 0 and 1, which is the only language a computer's CPU can directly understand and execute. Each processor has its own machine language, so it's specific to the type of computer.
Let's talk about assembly language. Assembly language is like a machine language that a computer can understand, except that assembly language uses abbreviated words like add, sub, div, or etc. in place of numbers, zeros, and ones. Next up, we've got memory. Memory, a physical device that is used to store data, information, and program in a computer, like RAM and storage devices. Kung why memory, why mahimo ang computer? Now, let's explore the artificial intelligence or AI. AI, an area of computer science that deals with the simulation or creation of intelligent machine or intelligent behavior in computers. They think, learn, work, and act like humans. Now, let's rewind to the first generation of computers from 1940s to 1950s. Main electronic component vacuum tube. Mao ni ang primary nga electric components. Nag-act ni sila isip usa ka switches og amplifiers. Main memory. Magnetic drums and magnetic tapes. Gigamit ni para mag-store og data og mga programs. Programming language, machine language. Mao ni ang programming language nga available. Power. Consume a lot of electricity and generate a lot of heat. Speed and size. Very slow and very large in size, often taking up entire room. Input or output devices, punch cards, and paper tips. Gigamit ni para mag-input og data og instruction sa computer. Pipila sa mga examples nga gikan ini nga panahon kay ang ENIAC, Electronic Numerical Integrator and Computer, Unicov 1, IBM 650, IBM 701, or etc. Quantity. There were about 100 different vacuum tube computers produced between 1942 and 1963. These machines, despite their limitations, paved the way for incredible technology we have today. So they're a crucial part of computing history.
Second generation, In the second generation, vacuum tubes were replaced by transistors which have the same functions as a vacuum tubes. But transistors were better because they were smaller than vacuum tubes, which made computer smaller and cheaper as well. Also, transistors were faster than vacuum tubes, so if you need 1 hour calculation and stuff with the first generation computers, you only need minutes with second generation computers. And it could operate longer since it doesn't generate as much heat as the vacuum tubes, so it's less prone to overheat. However, despite the upgrade, the way it was operated was still handled with punch cards, like in the first generation, but at least this time the storage was upgraded from the magnetic drum to magnetic tape. The size was big as well, but it could hold more data compared to a magnetic drum. Third generation. This time, computer finally started to look like computers of our era. That's because instead of wiring thousands of separate transistors like in the second generation, computers this time they use ICs or integrated circuits. Instead, so these integrated circuits contain a chip, and these chips actually contain a mini transistors in a microscopic size or even just a nanometer size. This was created directly on them using a process called photolithography, which is like drawing patterns with light to form the circuit. But not the most important thing is that computers began supporting keyboards with monitors, so people don't need to use punch cards anymore to operate them. Also, operating systems like Unix and IBM 360 started to show up as well. However, the interface at the time was still text-based instead of graphical like what we have today. And lastly, floppy disks started to show up, so they became the preferable storage for computers because they're more portable and convenient compared to magnetic tapes.
Fourth generation of computers. The main characteristics of fourth generation of computers. Main electronic component, a very large scale integration of VLSI and microprocessor. VLSI, thousands of transistors on a single microchip. Memory, semiconductor memory such as ROM, and etc. RAM for a random access memory, a type of data storage used in computers that require source of programs and data. Or ROM, or read-only memory, a type of data storage used in computers that permanently stores data and programs. The difference of the two: for RAM, it temporarily stores both programs and data, while ROM, it will permanently stores data and programs. Programming language, a high-level language such as Python, Java, JavaScript, Rust, Kotlin, and etc. A mix of both third and fourth generation languages. Size, smaller, cheaper, and more efficient than third generation computers. Speed, improvement of speed, accuracy, and reliability in comparison with third generation computers. Input-output devices such as keyboard, pointing devices, optical scanning, monitor, printer, and etc. Network, a group of 2 or more computer systems together. Examples of fourth generation computers include early microcomputers and personal computers like the Apple II and IBM PC, as well as mainframes and supercomputers like the Cray-1 and Star Wars.
Main electronic component based on artificial intelligence, the ultra-large-scale integration technology and parallel processing method. Millions of transistors on a single microchip. Parallel processing method used 2 or more microprocessors to run tasks simultaneously. Language, understand natural language, human language. Ang pasabutan ng human language kay lahi-lahi o languages to use para maka-perform o command nga i-perform sa computer. For example, is programming. Programming is being programmed by the programmer. Next is power. Consume less power and generate less heat. Sa power, ang pasabutan ni the less gamiton ang computer, the more ang user dili ka consume og heat sa computer. Next is speed. Remarkable improvement of speed, accuracy, and reliability. Sa speed, ang computer is importante kaayo kay kung high speed ang performance sa PC sa computer, walay cause of problem when it comes on operating the system of the computer. Next is size. Portable and small in size and have a huge storage capacity. Sa computer, not necessarily need ang sizes sa computer kay mas importante ang storage for huge application capacity na i-install sa computer. Input-output device, keyboard, monitor, mouse, trackpad, or touchpad, touchscreen, pin, speed input, recognize voice, speech, light, scanner, printers, etc. Sa input and output devices po, dapat ang user must know the types of hardware devices para in the future, dali na ma-identify nila ang mga importance and parts sa computer. Also to enhance their memory skill. That's all for my parts of our report. I hope naara mo nasabtan sa akong gipang explain based sa own understanding and
the computer. This amazing technology went from a government or business-only technology to being everywhere, from people's homes, workplaces, to people's pockets in less than 100 years. The computer is one of the most remarkable inventions in modern history. In less than 100 years, it has grown from being a tool limited to governments and large businesses into a device that almost every person can access today. In the early years, computers were massive machines used mainly for solving complex calculations, data processing, and military operations. They were costly, difficult to use, and far from being available to ordinary citizens.